Warm greetings and welcome to everyone. Today we are going to see about the shear force and bending moment for a simply supported beam with an eccentric point load. You take a simply supported beam is having a support at left end and right end, which is as A and B, and the point load is acting at a distance of 2 meter from the left support. This is 2 meter and this is 3 meter. You can take it, assume. So 10 kilonewton is acting downward at point C. So the point load is acting 2 meter from the left support and 3 meter from the right support. It is of 10 kilonewton and the span is 2 plus 3, that is equal to 5 meter. So what will be the reaction at support A and B? So here the support reaction at A is equal to the load W, this distance is B by total span L. So W is 10 into 3 divided by 5. So 30 divided by 5, you are getting 6 kilonewton. So the left support reaction is 6 kilonewton, which is upward. On the right support reaction is W A by L. So W is 10 into 2 into divided by the span of 5 meter. So you will get 4 kilonewton. If we add the reaction at RE and RB, that is 6 plus 4 is equal to 10 kilonewton. So the 10 kilonewton is acting at the point C under the point load C. So the total upward reaction is equal to the total downward load. So 6 plus 4 is equal to 10. So 10 kilonewton is equal to 10 kilonewton. So both are acting upward. The reaction is upward reaction. Then how will you find the shear force? To the left of section, the reaction is, I am taking a section to the left of point load 10 kilonewton. What will happen? Only the reaction RA, that is 6 kilonewton upward. So the shear force at A is equal to plus 6 kilonewton. Then what will be the shear force at the point load of 10 kilonewton? So if you are taking to the right of it, so this will be included 6 minus 10, because downward is 10 to the left of section. 6 minus 10, you will get minus 4. So when at the point of the point load, you will get as two shear force. One is upward 6 kilonewton and another is downward 6 kilonewton. So the shear force is right from A to C. It is a triangle of, so it's not a triangle, it is of constant value of 6 kilonewton. At the point load C, it goes to from plus 5 kilonewton to plus 6 kilonewton to minus 4 kilonewton. So the shear force diagram is going like this. So to the point AC, you are getting 6 kilonewton, then it changes position minus 4 kilonewton. So that is the shear force diagram. Then coming to the bending moment, you know that the bending moment is nothing but wherever the section is applied, you have to use the sign convention also. So I am taking at A, to the right of A, I am taking only this. So RA into 0, what is that? 6 into 0, 0. Similarly, the moment at B, what if I am taking right hand section? 4 into 0, because perpendicular distance is 0. So 4 into 0, 0. So at A 0, at B it is 0. But under the point load, what is the maximum value of bending moment occurs? That is WAB by L. That is 10 into 2 into 3 divided by 5. So 10 into 2, 20 into 3, 60, 60 divided by 5, you are getting 60 divided by 5 kilonewton meter. So that is the thing. That is nothing but 12 kilonewton into meter. So the maximum bending moment will be that at the point load. So it is of a triangle, so having 0 value and as reaching the maximum value, then coming to 0. So it will be like this. So it is a positive, that is sagging moment of 12 kilonewton meter. So you can able to draw. So all are positive, 0, 0. Then here it is 12 kilonewton. So it is a triangle which is having a maximum value at C, that is under the point load, which is of 12 kilonewton into meter, which is a positive moment. That is the sagging moment. So this is about the simply supported beam. We are drawing the shear force and bending moment, right? So you can able to draw the SFD and BM, that is shear force diagram and bending moment. So the maximum shear force occur under the portion AC, which is of 6 kilonewton, and minimum shear force is which is of negative shear force of 4 kilonewton. The maximum bending moment occurs under the point load, that is at C, which is of 12 kilonewton meter. So this is the answer for the shear force and bending moment values for a simply supported beam with the eccentric point load. In the previous video, we have seen about the central point load for a simply supported beam. So here we have done the problem on the simply supported beam with an eccentric point load, which is a 5-meter span, which is having a 2-meter eccentricity from the left support and 3-meter eccentricity from the right support. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.